So the following questions use the points A, B, and C, and these are just coordinates. So part A, it wants us to find the vector that joins A and B together. So before I get to that, I might draw myself a sketch to kind of help this out. So I'm going to draw the Cartesian coordinate system, so the X and Y axis, and let's plot our 3 points on there. So A is at the point 1, 3, so that's 1 along X, 3 up Y. Let's say that's that point. Alright, next we have B, so that's 2 along and 0 up, so it basically sits on the axis at 2, so that's point B. And C is at the point 3 across, and then -2, so 2 down. So let's say it's here. Make this a bit longer. So that's -2. Alright, so I want the vector that joins A and B in that direction, so from A to B. So let's draw that in, from A to B, that's that vector, AB with the arrow over the top. Now there's a couple of ways we can do this. One is to just kind of read it off the graph itself, because we can quite easily see how far it goes in the X direction and the Y direction. The other option you have is to actually take away the vectors. It's going to be B minus A to get from A to B. Okay, so if you want to use that method, it's worth writing out A, B, and C in vector form. And it's basically just a case of taking these and saying this is 1i plus 3j. This one is 2i, 0j. And this one is 3i minus 2j. And just for interest's sake, I guess, so this vector would be like here, from the origin out to your point. This one would be B, and then C, oh, maybe I shouldn't have written B there, this would be B, and then C would be this one. Alright, so let's actually sub these in and do it. So B is 2i minus A, so 1i plus 3j. So we're going to get 2 minus 1, so that leaves us with 1i. And then we've got -3j. Again, we could have got that just by looking at it for this one. So we can see that this vector here is 1 over in the x direction, so that's why it's 1i. And then 3 down, so -3j there as well. Alright, so that's the answer to part A. So part B, it's asking us to find the magnitude and direction measured counterclockwise from the positive x-axis for this vector that we've just worked with. So let me just draw it separately away from here. So we said it was 1i and then 3j going down. This is for part B. And this here is AB itself. And the length of that line, which is the magnitude, and that's what those bars mean, is what we're looking for firstly, so the magnitude of that vector. So we should be able to get that using Pythagoras' theorem, because we know that the x and the y components are going to be 90 degrees to each other. So this is going to be 1 squared plus 3 squared. So that is 1 plus 9, or square root 10. So that's the magnitude of that vector. So the other thing that it asked us for was the direction, and it needs to be counterclockwise from the positive x-axis. So this here is the positive x-axis. Counterclockwise, it's like opposite to a clock, so it's this way around. So if we're going to measure, this is the direction of our positive x-axis, we need to measure all the way around to here. That's the angle that we need to report. Now obviously that one's a little bit tricky to get straight away, so a good pre-step would be maybe to solve for this angle, which I'll call alpha. And then once we've got it, we know there's 360 degrees in a circle, so if we take away alpha from that, it's going to leave us with this theta angle that we need to report. So we have sine, cos, and tan, since this is a right-angled triangle. I might use tan. So tan alpha, that's what we're going for firstly. It's equal to the opposite, so that's 3, divided by the adjacent, which is 1. So alpha is going to be tan inverse of 3. And if you type that into a calculator, it comes out to 71.6 degrees. So we want theta, okay, again we said there's 360 degrees in a circle, minus that 71.6 degrees, it's going to leave us with what we're interested in, and that comes to 288.4 degrees. So that's the answer to that one. Might highlight these. Cool. Alright, so part C now is to find the vector CB. Alright, so from C to B. So we should be able to draw it. It's going to be like this. Alright, from C to B. So again, we have a choice of either trying to read it off our diagram. I might do that this time. Or alternatively, you can always use these vector expressions and sub in the same way that we did part A. So this is C. Alright, so looking at this diagram, in the x direction, it's going from 3 to 2, so that's in the negative direction, and it's 1, so negative 1i. And then we can see it's going upwards in the y direction, so it's going to be positive, and it goes from negative 2 up to 0, so that's going to be a distance of 2, so plus 2j. That there is the answer to part C. Alright, so part D wants us again to find the magnitude and direction measured counterclockwise again from that positive x-axis. So let's just draw out this again separately to make it easier. So what we know is that it's going 1 across and 2 up. And this is CB. Again, I'm putting the lines on here to show that it's like the magnitude. Alright, so we can get that using Pythagoras theorem. So it's going to be the square root of 2 squared plus 1 squared, which is the same as 4 plus 1, or 5. And then for the angle, again we want it measured from counterclockwise from the positive x-axis. So that's going to be this way round until we hit our vector. So that's the theta we need to report. Again, it's not really easy to get that directly. So I might go for this angle in here, which I'll call alpha first, and then we know there's 180 degrees in half a circle, so we can use that to then find theta. So it doesn't really matter again whether you use sine, cos or tan. I might use tan though. So it's going to be the opposite, which is 2 divided by the adjacent, which is 1. So tan inverse of 2. This is 63.4 degrees. And then theta, we said it's going to be 180 minus that 63 degrees in order to leave this remainder here, and that becomes 116.6 degrees. So that's the magnitude and that's the direction measured counterclockwise from the positive x-axis. Alright, so next bit, we want to find the unit vector in the direction of AB. Alright, so that's this vector here. So we want a unit vector, that just means it has a length of 1 in this direction. So let's go over here to do it. We should be able to use some of this information that we collected before. So we said AB already was equal to 1i minus 3j. And we have the magnitude, that's going to be useful as well. It's equal to square root 10. Alright, so a unit vector, often we use this kind of notation, the hat means unit. It's going to be equal to u divided by the magnitude of that vector u. So in our case, the unit vector in the direction of AB, it's going to be equal to our vector AB in this form, divided by the magnitude of it. So let's substitute that in. So we've got 1i minus 3j divided by the square root of 10. And we can make that look a little bit neater. You could write it as 1 on square root 10i minus 3 on square root 10j. Okay, that's all there is to it. So that there is a unit vector in the direction of our AB vector. So if we were to draw it on this diagram over here, all right, it'd be like this. This is our unit vector. I called it U with a little hat on. All right, its length should be 1 long. So if you go and do that calculation, it should be 1. By definition, that's because it's a unit vector. So I think that's pretty much it in terms of this video, and I'll see you in another one.